Hi, and welcome today. We're going to be talking about BigQuery and going through a quick labs where we get started using BigQuery in the console. My name is Leah Jarrett, and I'm a developer advocate for Google Cloud. These days, organizations have a lot of data. Imagine you're a software company. You probably collect data from all different places. Maybe you have customer data sitting in a CRM tool. Or maybe you have marketing information about who opened what email or who clicked on what ad. And even more impactful, maybe you have an entire history log where you have different customers clicking around in your application. That's a lot of data. So how do we actually process and make sense of all this information? Traditional data warehouses were not designed to handle the explosive growth of data. But this is where BigQuery comes in. BigQuery is an enterprise data warehouse that solves the big data problem by enabling super fast SQL queries, all using the power of Google's infrastructure. Storage, which holds your data warehouse objects like tables and data sets, is separate from compute, where we schedule resources to actually execute those workloads. These are decoupled so that they can scale independently, which offers huge flexibility and cost control for your organization. You don't need to worry about keeping expensive compute resources up and running or hope that compute resources become idle enough to shut down. You can access BigQuery in the console, the web UI, through the command line tool, or even through the BigQuery REST API using a variety of client libraries like Python or Java. You can also connect other tools to BigQuery to either load data into your data warehouse or maybe visualize or build dashboards off of this information. Now that you understand a bit about BigQuery, let's talk about what we're actually going to cover today. We're going to be walking through a hands-on lab that shows you how to use the web UI to query public tables and even load in some sample data sets. We're going to start out by doing a tour of the web UI so that you understand how to interact with BigQuery. Then we're going to look at some public data sets and even write a couple of queries. Next, I'll show you how to create your own data set and even load some sample data from a Google Cloud Storage bucket into a brand new table. And then finally, write a query against that table. So let's go ahead and dive in. Okay, so today we are going to walk through a quick labs that shows you how to get started with BigQuery's console. Now, if you've never used Quick Labs before, it's super cool because you get temporary access to a project inside of Google Cloud. So I've already gone ahead and signed in with the username and password that Quick Labs has given me. And now I can see that I'm in this new project. Now in this project, I can go ahead and test out these different services and walk through the learning path that Quick Labs has laid out for me to test out different aspects and learn how to use BigQuery. If you haven't used Google Cloud before, projects actually form the basis for using all of the Google Cloud services. So all the different APIs and products, you're going to need a project to go ahead and access them. A project is also tied to a billing account. So in this case, we're just working through Quick Labs, so we don't need to worry about a billing account. But for our own organization, each project will be tied to a billing account. And this is important because your BigQuery usage will actually be billed to this account. So if different teams want to be billed separately for their queries, you're going to need to have those queries run in different projects. So since we're talking about BigQuery, let's go ahead and get started by navigating to the BigQuery web UI. And like we said before, the web UI is just one way that we can interact with BigQuery. Now, before we actually get started, let's just take a quick tour of the web UI itself. Front and center, we have our query editor where we can, of course, write queries, run them, save them, schedule them, and so on. And on the left-hand side, we have some other actions that we can take inside of BigQuery, like set up a data transfer, which means that we set up a transfer of data coming from an external application directly into BigQuery's native storage. We can set up different scheduled queries, or we can commit to purchasing slots or compute resources. and actually assign those resources through reservations to specific projects or folders where they can handle certain workloads. This is what we call flat rate pricing. And in case you aren't familiar, BigQuery has two different pricing models. Flat rate, where we're purchasing those commitments to buy compute resources, what we call slots, or on demand, which is what we'll be using today. On demand is the default, and it's perfect for getting started with BigQuery because you only pay for what you use. You get billed for the amount of bytes that your queries are actually scanning. And then last on this list, we have BI Engine, which is a really cool brand new BigQuery feature that allows you to reserve capacity within an in-memory query execution engine. So basically, you say you want to purchase X number of gigabytes of memory, and then BigQuery is going to intelligently cache data so that your queries are super fast and performant, which is especially useful for if you have a business intelligence report that needs to run really fast. Okay, so back to the editor. Now on the left-hand side, I can see my different pinned projects. These are projects that I have access to where I may want to see the data that's stored within them. Now, my project that I have here, I just generated, so it actually doesn't have any data living in it yet. Up here, I have the project where my queries will actually be run. So like we talked about before, storage and compute are separate inside of BigQuery. So think of this project as where your computation is actually occurring, but these projects over here show where my data is actually stored. Now let me go ahead and click Add Data, because since we don't have data yet, we need to pin a new project so we can start querying. Here I can click Explore Public Datasets, and this brings me to Google Cloud's Marketplace. In the Datasets page of the Marketplace, I can explore all the different datasets available through BigQuery Public Datasets program. This program is super awesome because our data engineers take care of cleaning, transforming, and loading the data into BigQuery so that you don't have to. There are tons of really useful data sets. For example, census data, data about different financial institutions like cryptocurrency. We have a ton of COVID-19 data sets and even specific ones for healthcare, life sciences, and like we said, financial services or even education. So today I'm going to work with the births data summary dataset that comes from the CDC. Now from this page, I can look at different samples which show me queries that I can write against these different data sets, or I can even view the data set directly in the console. But instead of doing that, I'm going to start by clicking Pin a Project and entering a project name. I'm showing you this because in BigQuery, you might have data stored in lots of different projects that you want to query together. So pinning it to this resource tree on the left-hand side is going to make your life a lot easier. You'll be able to see all of your tables in one place and directly query them from the same editor. So in this case, my data set, or project name rather, is called BigQuery Public Data. I can pin it. And now, like I was saying before, we can actually see the data that's stored within this project. Let's go ahead and open up this project and I can see all my different data sets. Now, if you've used other database systems, a project in BigQuery is kind of like a data set, and a schema or a data set is kind of like a schema. So each one of these data sets contains different tables stored beneath them. So I'm going to go ahead and search for that births data set that I was looking at before. Now I can see my data set, and again, all these different tables stored nested beneath them. What I can do is click Open to actually view this data set. Thanks, Google. I can see metadata information like, the description of the data set and also labels against the data set. Now, labels are really great because you can create key value pairs to organize your data sets or your tables. So a good example is if you want to track cost center, environment like staging or production, or even the specific team that's using this resource. I can also see information about if the data set is set to expire, when it was created, and the location what the data is being stored. Now this is important because BigQuery will not let you query across data that's stored in different locations. This data is actually stored in the multi-region location, the US. Now, if I have data stored in another region, I won't be able to write a query against them, like we said, so make sure that you're keeping this in mind when you're structuring your own warehouse. Let's also go ahead and open this table that we're going to write a query against. When I open the table, in that same detail panel, I can see information about this table. So first up is my table schema. And a table is basically a collection of data that's organized into rows and columns, right? So each row represents one record, one piece of information, and it's organized into different columns or fields. So we can see the names of those columns, and we can see the type of data. So, for example, we have the year that which this data was collected, and this is a type date. And we can also have individual descriptions for each of those columns, which is really useful, especially if you're doing some calculation and you want your team to know exactly how this data was calculated or where it came from. Now on the details page, I can see more metadata about this table, like the table ID, the size of the table, number of rows, when it was created, when it's going to be expired, and again, descriptions and labels. I can also preview this data to see, what it looks like. And like we said before, a table is just going to be a collection of rows or records organized into different columns. So we can see that this data actually tells us for each year, for each county, the number of births, and some other statistics like the average age of the mother and average birth weight and so on. Now let's actually go ahead and write a query against this table. I'll click query, and now I can see these two side by side. So I can see information about my table on my left-hand tab, and then I can see the query that I'm writing over here. So maybe let's start by just selecting my year, maybe the county of residence, and as you can see, BigQuery will try to autocomplete some of those column names or things as you're typing along. And maybe let's look at the number of births. And let's limit this to just 10. I'm going to go ahead and move this over so it's a little bit easier for us to see. And actually, let's just move this over even more. So now what I can see are the results of my query. I can see it just as a table or even as a JSON. And what I can also see is this job information. So what's going on here is that BigQuery sees that we want to write and execute this query. So what it does is behind the scenes, it creates a job. And jobs are executed asynchronously inside of BigQuery's execution engine. So now I can see information like the job ID, which contains the project where my job actually ran. Again, this is important because our data is actually stored in one project, that BigQuery public data project. That will be where storage is billed. But my job ran in this project over here, my Qwik Labs project. So this is where my compute will actually be billed. I can also see information about this job, like who ran it. So me, my Qwik Labs user ID or user email, the location where it ran, and the job is going to run in the same location as where the data is stored. I can also see like how long it took to process, how many bytes it processed, how many bytes were billed, etc. Now all this information is available in the console, but we can also get it through the API, and metadata like this is available through BigQuery's information schema. This is important to note because maybe your team wants to do analysis about the types of queries that are being run. For example, how long they're taking to run on average, to pinpoint queries that are maybe taking a really long time and need to be optimized further. Now this right-hand panel is really interesting. This is execution details, and this is where we can see information about how the query was actually executed behind the scenes. Now, BigQuery often breaks a query up into several stages. This one just has one stage, and we can open up this little caret to see the details. There's a lot of really interesting information here, and I'll just talk about it for a few moments, but this documentation right here helps you really drill into details. And as you're ramping up on BigQuery and maybe executing some really complex or expensive queries, the execution details will help you understand what's happening so that you can make decisions around changing the storage of your data, changing the way the query is being written to make it faster or more performant, or even cheaper. So BigQuery executes queries in a distributed fashion. We have a bunch of different workers that are each doing some part of the query at the same time so that we can process huge amounts of data in parallel. Now, what these statistics show us is basically an average and a max of all of our different workers and what's happening at each stage. So in this stage, our workers spent an average of 15 milliseconds waiting around, maybe for something to free up or for a different worker to complete their own work. We also have the time that's spent actually reading in the data, doing CPU tests or doing computational work, and writing this data out to either distributed storage or to what we call BigQuery's in-memory shuffle, which allows us to save intermediate results at each one of these stages so that other workers can read those results and do something with that information. Now, this is a really simple query. I'm just doing some selects, so it's a pretty simple query execution plan. We just have one stage where our workers are each reading in some data and then limiting it to just 10 rows and then giving me the results. But let's make this a little bit more complex. Maybe I'm just going to say for each year, I want to know the average number of births that happened across all of my different counties. So let's select year, average births. Now I'm going to add my group by statement. And maybe let's add an order by statement too. I'm going to order by that second selection. So now what we have is we want to basically know the top 10 years where the average number of births across all of our counties were the highest. So let's go ahead and run this query. I can see the results, and let's go back to the execution details. And now this query plan got a whole lot more interesting, right? We have 3 different stages that are happening. We have our first stage where we're actually, reading in the data from BigQuery's storage. We're doing some first pass aggregations where we're maybe aggregating, each worker is aggregating up to that year and taking the average. But you might have one worker that has the year 2000 and another worker that has the year 2000. So in this second stage, we're actually going to combine all the results from our different workers and sort them so that we have one worker that ends up with all of the birth records from the year 2000 and so on. Then our last stage, we're going to actually output the results and write the results to our persistent storage so that we can see the results. And one other thing I like to point out here is that BigQuery is going to store all these results in a temporary table. And this is so that if someone else runs the query, then we're going to have it be super fast because the results are already cached and stored in this temporary table. Great, so at this point, you should have a good idea of how to interact with BigQuery's web UI. You also learned how to access public datasets, pin different datasets over here, run a query, and a little bit about how to work with the execution details or the query plan. So now let's talk about one of the first things that everyone does when they get started with data, which is loading data into your warehouse. So let's go back, and like we said before, we have this project, but no data is stored in it. In order to store data, we're going to have to first create that data set. Now, we're going to be working with some publicly available baby names data that's provided by Qwik, so let's call it baby names. And we can set a location for our data set. Let's set it to be the US multi-region. And I'm going to use Google managed encryption keys, but I can also use customer managed encryption keys where I create my own encryption keys. Let's go to that data set. Awesome. So now I can see my data set has been created. Great. Like we said before, I can give my data set some more metadata information like a description. I'm going to put some cool baby names data here. And I can also create different labels and key value pairs to help everyone understand what's actually in this data and to make monitoring information a lot easier. Next thing I want to do is actually create a table. But before I go that far, I am going to actually need to grab that data that Qwik provides and get it into my Google Cloud project. So I'm going to stage this data in a Google Cloud storage bucket. Let's go ahead and create a storage bucket. Go ahead and create that bucket, and I'm going to call this Leah Baby Names Demo. We'll keep these all as the standard. Great. And now I am going to need to basically copy some files from a public Google Cloud storage bucket and push them into my own brand new storage bucket. So to do this, we are going to activate the Cloud Shell, and we're just going to copy some of the commands that are given to us in the Qwik Labs console. So let's go down here to Add Custom Data. And I am going to start by copying this command right here. This basically copies files from this public Google Cloud Storage bucket. Oops, and I forgot that period. Now let's go ahead and actually unzip this file. Now we have a bunch of different text files. And now I need to actually copy one of those files into my Google Cloud Storage bucket. So I'm going to need to type in the name. Let's call it Baby Names Demo. Great. And now let's go ahead and refresh this page. And now I can see this text file available in my Google Cloud Storage bucket. Awesome. So now that I have this available in my storage bucket, let's go back to BigQuery and import this data into a BigQuery native table. So let's open my data set. I'm going to click Create Table. And we can create a table from a bunch of different data sources. So we could create an empty table, which might be really useful if we want to later add rows through the API or through some ETL pipeline. We can bring in data from Google Cloud Bigtable, bring in data from Google Drive, maybe if you have it in a Google Sheet. I can upload a file directly from my local computer, or in this case, I'm going to bring data in from my Google Cloud Storage bucket. So let's go ahead and bring in my text file. In this case, I know that this is a CSV file. Now I already have selected my project name, my dataset name, and we're going to keep this as a native table, which means that the data will be stored in BigQuery's native storage, as opposed to keeping the data stored external to BigQuery. So now let's go ahead and give my table a name. I'm going to keep with my theme and maybe call it Baby Names. And I could try to use schema auto detect, which will try to figure out the column names and column data types, but I don't have to do that because I actually already know what my schema is. Let's go ahead. I think the first thing is my baby's name. And then we have a count, which is an integer. And I think there's one more field. Let's go ahead and check back into Qwik Labs, name, gender, and count. Great. So I'll add in one more field. Let's make this one gender. And we'll call this count. Put it as an integer. Great. And the next step is you can also configure partition and cluster settings. Now, in this case, I'm just going to leave it as no partitioning, but this might be really useful for if you have a really big table. Partitioning allows you to basically segment your data stored into different blocks. For example, if I want to partition my transactions table based on the transaction date, this means that a lot less data is going to be scanned when I filter on that date because BigQuery knows it only needs to go into certain or open up certain segments of the file. I can also use clustering, which basically determines the sort order of the data. So for example, with that transactions data, I might want to cluster on my customer ID. This can, again, improve how much data is scanned by applying filters, and it can also make some different aggregations or joins more performant. So let's go ahead and create my table. Now my table has been successfully created. I can see again my table schema, the details, and even preview it. So everything looks great. Let's go ahead and write a query against it. So maybe I want to know for each gender the total count. So let's do sum of count and maybe call that total count. And let's do group by one. Cool, so now we have our query results. And there's a lot of stuff we can do with this, right? I might want to save the results and save this as a CSV file into Google Drive or locally. Same thing as a JSON file. I can also save this as a table in BigQuery or even save it as a view or just save my query to, my personal folder. I can schedule this query, or I might want to explore this data in sheets, connected sheets, which allows me to, work with it in a spreadsheet environment or within a business intelligence tool like Data Studio. And so, yeah, now you know how to add some new data from Google Cloud Storage bucket and write a query against a brand new custom table. Now, since I've written a couple queries at this point, I do want to point out something down here, which is the job history, query history, and saved queries. So I might want to actually look at job history. This is where I can see that a load job happened coming from my Google Cloud Storage bucket. I can also look at the query history and I can see my queries that were run. And again, this information is available in the console, but it's also available through the API in case you want to do some analysis on seeing, what types of queries people are writing in your organization and use that to help prioritize, maybe optimizing different queries or optimizing storage of those data sets. Great, thanks so much for joining me today. You probably learned all about how to interact with BigQuery through the web UI, how to explore and query public data sets, and how to even create your own data set and table and load in sample data. So I hope you're well on your way to getting started with BigQuery. Thanks.